In situations where placing a disconnecting means within sight of equipment is impractical or introduces additional hazards, alternative approaches are permitted under specific conditions. One key reference is the National Fire Protection Association 70E, specifically Section 110.26. This section addresses workspace about electrical equipment operating at 600 volts nominal or less to ground. This section provides an exception that allows for the omission of the disconnecting means from sight of the equipment. This exception is applicable where such a location of the disconnecting means is impracticable or introduces additional or increased hazards to persons or property. It's crucial to carefully evaluate the specific circumstances to determine if this exception applies. The assessment should consider potential risks associated with both having and not having the disconnect within sight. Furthermore, in industrial installations, another condition permits the disconnecting means to be located out of sight of the equipment. This is allowed when written safety procedures are in place and conditions of maintenance and supervision ensure that only qualified persons service the equipment. The written safety procedures must detail the steps to be taken to safely de-energize the equipment and verify that it is indeed de-energized before any work is performed. Qualified persons are those who have the skills and knowledge related to the construction and operation of the electrical equipment and installations and have received safety training to recognize and avoid the hazards involved. The term qualified person is very important here. The level of training, experience, and competency are key factors in determining who can safely work on electrical equipment. The employer is responsible for determining who is qualified. It is imperative that electrical safety programs must be detailed. Firstly, hazard identification needs to be performed. Secondly, risk assessment should be performed. Thirdly, the risk control methods need to be outlined. Fourthly, job planning needs to be performed. Fifthly, electrical safe work practices are needed. Sixthly, safety procedures need to be set in place. The procedures need to be enforced to ensure that unqualified people do not service the machinery, but only qualified personnel. The written safety procedures should include, at a minimum, firstly, a detailed description of the steps to be taken to de-energize the equipment. Secondly, procedures for verifying that the equipment is de-energized, such as using a voltage tester to confirm the absence of voltage. Thirdly, methods for preventing unintentional re-energization, such as lockout/tagout procedures. Lockout/tagout procedures are critical for preventing accidental energization of equipment during maintenance or repair. Lockout involves placing a lock on the disconnecting means to prevent it from being turned on, while tagout involves attaching a tag to the disconnecting means warning others not to turn it on. In addition to the written safety procedures and qualified personnel requirements, regular audits and inspections should be conducted to ensure that the electrical safety program is effective. These audits should identify any potential hazards and ensure that all safety procedures are being followed. Consider an example where a large piece of industrial equipment is located in a confined space. Placing the disconnecting means within sight of the equipment would make it difficult for qualified personnel to access the equipment for maintenance and repair. In this case, the disconnecting means could be located outside the confined space, provided that written safety procedures are in place and only qualified persons service the equipment. Another example would be a situation where the disconnecting means is located in an area with a high risk of arc flash. Moving the disconnecting means to a remote location could reduce the risk of injury to qualified personnel. Arc flash is a dangerous electrical explosion that can occur when a short circuit creates an arc of electrical energy. It is important to assess the arc flash hazard and implement appropriate safety measures to protect workers. These measures may include wearing appropriate personal protective equipment such as arc-rated clothing, gloves, and face shields, as well as using remote switching devices to operate the disconnecting means from a safe distance. The decision to omit the disconnecting means from sight of the equipment should not be taken lightly. It should be based on a thorough risk assessment and careful consideration of all relevant factors. If there is any doubt, it is always best to err on the side of caution and locate the disconnecting means within sight of the equipment. Always consult with a qualified electrical engineer or other expert to ensure that the installation complies with all applicable codes and standards. In summary, while a disconnecting means is typically required to be within sight of the equipment it serves, exceptions exist. Firstly, increased hazards. Secondly, impractical placement. Thirdly, industrial settings with rigorous safety protocols and qualified personnel. These exceptions are outlined in NFPA 70 Section 110.26 and should be carefully considered and implemented in accordance with applicable codes and standards. Always prioritize safety and consult with qualified professionals when making decisions about electrical installations. It is essential to remember that electrical safety is not just about following the rules. It is about understanding the risks and taking steps to mitigate them. This requires a strong commitment to safety from both employers and employees. Regular training, effective communication, and a culture of safety are all essential elements of a successful electrical safety program. In addition to NFPA 70E, other standards and regulations may also apply to electrical installations. These may include the National Electrical Code, the Occupational Safety and Health Administration regulations, and state and local electrical codes. It is important to be familiar with all applicable codes and regulations and to ensure that all electrical work is performed in accordance with these requirements. The National Electrical Code, or NEC, is a widely adopted standard for electrical installations in the United States. It provides detailed requirements for the safe installation of electrical wiring and equipment. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. OSHA, or the Occupational Safety and Health Administration, is a federal agency responsible for ensuring the safety and health of workers in the United States. OSHA has a number of regulations that apply to electrical safety, including regulations for lockout/tagout, personal protective equipment, and electrical safe work practices. States and local electrical codes may also have additional requirements for electrical installations. These codes may vary depending on the location, so it is important to check with the local authorities to determine which codes apply. It is important to have a grounding and bonding system. Firstly, equipment grounding conductors connect non-current carrying metal parts of equipment to the system grounded conductor. Secondly, bonding jumpers ensure electrical continuity and conductivity. Thirdly, ground fault circuit interrupters protect against electrical shock. Following these guidelines can help minimize risks and create a safer work environment. Consider the specific requirements for conductor ampacity and overcurrent protection to protect circuits and equipment. Firstly, consult the NEC tables for conductor ampacity based on insulation type and temperature rating. Secondly, use overcurrent protection devices, such as circuit breakers or fuses, to protect conductors from overload and short circuits. Thirdly, ensure that the overcurrent protection device is properly sized to protect the conductor. The selection and installation of electrical equipment in hazardous locations requires special consideration due to the presence of flammable gases, vapors, or dusts. Firstly, identify the class, division, and group of the hazardous location to determine the appropriate type of equipment. Secondly, select equipment that is specifically designed and approved for use in the identified hazardous location. Thirdly, follow all manufacturers' instructions and applicable codes and standards for the installation of electrical equipment in hazardous locations. Electrical drawings and documentation are essential for understanding and maintaining electrical systems. Firstly, ensure that electrical drawings accurately reflect the as-built conditions of the electrical system. Secondly, maintain a complete and up-to-date set of electrical drawings and documentation. Thirdly, make electrical drawings and documentation readily available to qualified personnel. A good electrical safety program is a continuous process that requires ongoing effort and attention. By following the principles and practices described, you can create a safer work environment for yourself and your colleagues. Regular training and refresher courses help keep workers informed about the latest electrical safety practices and procedures. Training should cover topics such as hazard identification, risk assessment, lockout/tagout, personal protective equipment, and electrical safe work practices. Effective communication is essential for creating a culture of safety. Workers should be encouraged to report any potential hazards or safety concerns to their supervisors. Management should be responsive to these concerns and take prompt action to address them. A culture of safety is one in which safety is valued and prioritized at all levels of the organization. This requires a commitment from both management and employees. When safety is a priority, workers are more likely to follow safety procedures and to take steps to protect themselves and their colleagues. In addition to the technical aspects of electrical safety, it is also important to consider the human factors. Human error is a major cause of electrical accidents. By understanding the factors that contribute to human error, you can take steps to reduce the risk of accidents. These factors may include fatigue, stress, distractions, and lack of training. Electrical safety is a shared responsibility. Everyone has a role to play in creating a safe work environment. By working together, we can prevent electrical accidents and injuries. The knowledge and implementation of safety procedures can prevent injuries and save lives.